All right. So this is what you would see when you analyze your data using Man-Whitney U-test, and you will find out that those infants or those babies, uh, all right. I was telling you that those children, those children who were given, who were given the parental care in the first trimester having the average weight of 25.50, and those babies uh, who were given parental care in the third trimester, or the sixth, seventh, and eighth month, or seventh, eighth, or ninth month, they were given the child the parental care. They have a mean weight of 75.50. So we can say that the babies with the third trimester having more average weight as compared to the babies who were given parental care in the first trimester. So there is a significant difference between the average weight of parental care children between first trimester and third trimester. So this is how you can interpret. Just a minute. So this is the way you can interpret in APA style. The result indicates that there is a significant difference in the median weight of infant between trimester 1 and trimester 3. The finding indicates a significant increase in the trimester 3 weight. I have put it here, the mean ranks or mean weights, that is 75.50 as compared to the trimester 1. And this is the Z value, which is also greater than 1.96, and the P value, which is less than 0.05. So it accepts the H1. So this is how you can apply the procedure. Uh, I would require you to apply this procedure in example 7, but let me first apply it using example number 6 on the data that I have provided to you. You are having this type of data set where there is a third folder, not normal. You may open example number 6 data set, and first you need to check the normality of the data using the procedure that we have. Example, you need to put the weight data. You need to change the measure, which is scale, and this is the categorical variable. So always remember that never test the normality of a categorical variable like this. You need to test the normality of your continuous variable. So weight is a continuous variable, so you need to check the normality of your continuous variable using this procedure that we were already dealing with. So here you can see that normality of data, the value of asymptotic sig value is less than 0.05. So we may consider that we are going towards the non-parametric procedure. And how we can apply the non-parametric procedure for testing two groups of variable? It is basically the two independent sample case. Under the one sample case, you can see the two independent sample case. You need to select it, and you need to put your continuous variable in test variable list, and you need to put your categorical variable into grouping variable list, and you need to check your values over here. Just a minute. We need to check our values over here. uh, we need to check here what values do we have for our variable. Like for trimester 1 we have 1, and for trimester 2 we have 2. So we have number 1 value and 2 value. So we need to put these into our analysis. procedure. So just go to independent sample. You need to put continuous variable here, care variable here, and then define variable. You need to put those values over here, like 1 and 2 that we seen over there. Just click continue, and you need to check or need to confirm whether man Whitney U test is selected or not. If it is selected, just click OK, and you will see the result like this. So I have already interpreted these results. You can see in the trimester one, the mean rank of the trimester one care babies were 25.50, while the care provided to the baby, the mean weight of the care provided in the third trimester was greater, that is 75.50, and it is significantly different. So we have interpreted this data set, and you need to apply this procedure on example number 7. You are provided expenditure data of 40 individuals, male and female. Can you conclude that there is a significant difference between the median spending of male and female? So you have a data set of example 7. So I will be giving you 15 minutes break. If you want to take tea, if you want to drink water, or you may also analyze example 7 data during this 15 minutes. And if you have any question, you may ask. Till then, I am just stopping or pausing the recording so that we can have a short break of 15 minutes. So in this 15 minutes, you will analyze the example 7 data using the same procedure that I have explained right now. You would apply this. All right. We will start again from the remaining part. The remaining part is regarding the more than two groups analysis, mean analysis. So that is the last part. So we will start at 7:45 p.m. according to Pakistani time. So if you have any question, you may ask during this period. All right, this is the last part of mean comparison, which is the mean comparison between more than two groups. So when we are dealing with group comparison or multi-group comparison, where there are more than two groups, so how can we consider the analysis using SPSS? So this is the final part of our basic level of SPSS analysis. Then this is Quantitative Primary Data Analysis SPSS 27 online training using Zoom. I am your trainer Zahid Bashir, and this is the final part of our basic level of Quantitative Primary Data Analysis. So here it comes. More than two groups mean comparison. This session will start at 7:40 and it will complete, and I would like to complete it before 9 p.m. and I am hopeful that it will be completed at around 8:30. So in case of more than two group comparison, it will be dealt with, and what are the subcategories of more than two group comparison and what type of cases we are dealing with. First of all, you like to know what is more than two group mean comparison. More than two group mean comparison, also known as multi-group comparison. So whenever someone asks you to consider multi-group comparison, it means that you are dealing with more than two groups mean comparison. It involves comparing the means of three or more groups to determine if there are statistically significant differences among them. If you recall your memory, our first session on mean comparison was the comparison of the single group with a standard value, while the previous one was the comparison of the two groups, two independent groups, and this is basically the comparison of three or more groups. So when we are dealing with three or more groups, in order to compare some criteria or some value, we are dealing with multi-group analysis. So how can we deal it? This type of analysis is commonly used in research and experimental studies. to assess variations in outcomes across multiple conditions or populations. There are several statistical methods for conducting multi-group mean comparison, and they can be broadly categorized in the analysis of variance and non-parametric tests. So, what will we do in multi-group mean comparison? There are certain examples like from medicine and healthcare profession. You might be interesting. You might be interested in investigating the impact of three different exercise regimens on weight loss on obese individuals. So you would like to know, or you would like to determine if there are significant differences in the mean weight loss across three exercise regimens, helping healthcare professionals recommend the most effective approach for weight management. You may be interested in educational domain and you would like to assess the influence of three teaching methods on students reading comprehension skills in elementary school, and you would like to use one way ANOVA to examine if there is a significant differences in mean reading comprehension scores among students exposed to different teaching methods, guiding educational practitioners in selecting the most effective instructional approach. In psychology domain, you may be interested in examining the effect of various stress reduction technique on anxiety level in different age groups, uh, like the application of which may be you are conducting a two-way ANOVA considering stress reduction technique and age group as a factor to determine if there are significant main effects and interaction effect on mean anxiety reduction, aiding psychologists in tailoring intervention for specific age groups. You may be interested in some situations in finance and economics domain that you would like to analyze the impact of three different investment strategies on portfolio return in various market conditions. For example, you would like to use two-way ANOVA considering investment strategies and market condition as a factor to assess if there are significant differences in mean portfolio returns, guiding investors in selecting the most suitable strategies based on market conditions. In market domain, you may be interested in comparing the effectiveness of three advertisement campaigns in promoting a new product in different demographic segments, and you may be interested in applying a two-way ANOVA with factors of advertising campaign and demographic segments to determine if there are significant differences in mean consumer response, resisting marketers in refining advertising strategies for specific target demographics. And last but not the least, because I am just giving the examples of different domains, there may be a lot of another other examples from other domains also. You may be interested in environmental study and you would like to investigate the effect of three land use management practices on soil erosion in various ecological zones, and you may want to use two-way ANOVA considering land use practice and ecological zone as a factor to assess if there are significant differences in mean soil erosion rate, providing insight for sustainable land management practices across different environments. So these are basically some of the examples that you might consider in multi-group analysis, and you are seeing that the word three is repeating again and again, but it doesn't mean that multi-group analysis only comprise of three groups. There may be more than three groups. So you are dealing with a situation where more than three or more than three groups may be considered for the purpose of comparison of some mean value. So this is basically the multi-group analysis. So what we do when we would like to apply uh, the SPSS procedure, what type of situation we may consider. So there are also three situations: normal data with equal variance, where we would apply the one-way ANOVA. So if our data is normal and our variance is equal, and we basically assume that our variance is equal across groups. So we may consider one-way ANOVA. If our data is normal but our variance is not equal, we may consider Welch ANOVA, And if our data is not normal, we may consider critical values test. So these are the three situations that we are going to learn in today's session. So let's start the first situation. How would you analyze the data using SPSS? First, we need to check the normality of the data using the same procedure that we have done previously. Then you need to decide about appropriate test. If your data is normal, you need to consider one-way ANOVA. And if your uh, variance equality of variance is confirmed, you may still need to use the one-way ANOVA, or otherwise you may need to Welch ANOVA. Next is the SPSS procedure. This is the same procedure I have defined, testing the normality. Then you will decide either you are going towards the parametric test, and in parametric test you have two options. If you are using one-way ANOVA and equality of variance is confirmed through Levin test is greater than 0.05, the sig value, you are considering one-way ANOVA. If the variance is assumed to be unequal using the Levin test, which is less than 0.05, you may use the Welch ANOVA. And if your data is not normal, you are going towards the critical values test, which is the non-parametric procedure for more than two groups. So this is the normal procedure. How will you apply? So here comes the case one. What will you do when your data is normal and your variance is assumed to be equal? So when your data fulfills the normality assumption as well as equal variance assumption, the test appropriate for two group mean comparison of such data would be one-way ANOVA. So your two conditions should be met: normality as well as equal variance in multi-group analysis. So you would consider one-way ANOVA. One-way ANOVA is used to compare more than two groups on the basis of their average. What is one-way ANOVA? One-way ANOVA is considered as a analysis of variance. Is a statistical technique used to compare mean across two or more groups to determine whether there is a significant differences among them. It is particularly useful when comparing mean across a single independent variable with three or more level or groups. It means there should be one continuous variable. It may be interval scale variable or it may be ratio scale variable. So you are going to compare that variable with more than two categories or groups. The objective is to test the null hypothesis that there is no significant difference in the mean of the group. So how we will deal with such situation, and what are the assumptions? The first assumption is independence. Observation within each group must be independent of each other. It should not be possible for the value of one observation to affect the value of another observation with the same group. The second is normality. Your dependent variable should be approximately normally distributed within each group. By dependent, we means the variable with continuous data type, with continuous type as a data. The interval scale or ratio scale variable is basically the dependent variable. So, however, ANOVA is known to be robust to violation of normality, especially when sample size are large. So, always remember, if the sample size is greater than 30, we may assume the data to be normal, and we don't need to check the normality of data. Homogeneity of variance, your variance across all groups should be equal. This is the assumption for applying the one-way ANOVA. The next is random sampling. Your data should be selected through random sampling approach, and your dependent variable should be either the interval or ratio scale. It should be continuous variable. So the time is going to end for this meeting, and please use the same link for the next meeting. Use the same link as I have previously shared with you.